Hello scholars, welcome. Mr. Hinkle here. Let's talk about the principles of relative age dating, and today we will go through all of our principles of stratigraphy, wrap it up with the Grand Canyon example because it's so amazing. So first off, the surface of the earth is blanketed by sedimentary rocks. They cover 75% of continental crust. There's an average thickness of about 6,000 feet or just over a mile, which can vary quite substantially. And it is thanks to sedimentary rocks. They're the history books of Earth. They contain past climates, past life, conditions at deposition. They really help us understand what was going on in Earth's past. They're like a window into our history. So thank you, sedimentary rocks. And sedimentary rocks can be dated relative one to another. So we have these examples and these questions. We have a rock with a fossil here and a rock with a fossil here. Which rock is older, this one or this one? We have all these cool rock layers. There's the layer at the bottom, A, and a layer at the top, B. Which rock layer is older, A or B? Well, the principles of stratigraphy and the principles of relative dating help us to answer these questions. And so here we go. Principle of superposition basically states that the rocks on the bottom are older than the rocks on the top in an undeformed sequence. So in order for these rocks to be here, they must have been deposited on the rocks below them. It's kind of like this. These rocks first, then those rocks, then those rocks. The rocks that are deposited on top every time are younger. So when we look at the beds down here at the water level and the beds up here high up in the image, which rocks are older? If you said the rocks down at the bottom, you are correct. Youngest at the top, oldest at the bottom. Principle of superposition. Principle of original horizontality. So this is a really cool road cut along Highway 14 right outside of Palmdale. You've got all kinds of awesome folds. You've got a big fault that runs through there, another fault that runs through here. So this is a deformed sequence. But this is not how it started. The deformation occurred after deposition occurred. And so in order for these rocks to be all squiggly like so, at first they must have been flat. Later tectonic forces shifted them into the way that they look. So this is called original horizontality, which, just like it sounds, it means that the rocks originally were originally horizontal. They were laid down flat. So our second principle, original horizontality. Well, let's say, according to this model, we got a big canyon, something like this, like a Grand Canyon. But the rocks on one side of the canyon, over here, are the same as over here. A is A, B is B, and C is C. Well, you could interpret that at one point the rocks went all the way across. They were laterally continuous. So this is the principle of lateral continuity, saying that even if erosion has occurred, the rocks were there at one point. The Grand Canyon was carved, meaning that all of the rocks at one point continued from one side of the valley, one side of the canyon, all the way to the other. So, next principle, lateral continuity. That's a cool one, I like it. This one is showing us the principle of cross-cutting. So here we see a big mass of bedrock, and then there's a very dark layer of rock in here there's even a white layer of rock in here. So 3 events have happened. First, you have the gray rock, which was infiltrated by this white quartz dike, which was then later cut across by a very mafic dike, meaning that in order for these 2 rock layers to be here, the gray rock had to be here first. First the gray rock was here, and then this lighter rock cut into it, and then the dark rock cut into it. So the principle of cross-cutting relationships states that the igneous intrusion is always younger than the rock in which it intrudes or it cuts into. Okay, I'm going to keep going through these. I know, boom, 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 there's a lot of them. Inclusions. So here we see a big chunk of this pink rock included in the black rock. Well, if the pink rock didn't exist, then it couldn't be a part of the black rock. So that means that the rock that contains the inclusions is younger. The rock that is included is older. Principle of inclusions. In order for this to be included here, it must have existed already. So the pink rock is older than the black rock. This is called the principle of inclusions. Shall we keep going? Yeah, what the heck? What about when rocks are really far away from each other? How do we correlate them? Well, we can correlate them using fossils. So rocks that contain the same types of fossils must be the same age. And if it's the same rock type with the same fossils, then we could say that those are the same rocks. And if we see, so fossil, fossil, fossil here, we could say superposition, this is the youngest, this is the oldest. Fossil, 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 same thing, youngest to oldest. Okay, now we're getting back to relative age dates. So this one is going to be fossil succession. Very helpful for creating and curating the geological timescale, especially before absolute dates were put on all of these. So if we apply these to our example of the Grand Canyon, I want you to take a second and think about which of these we can right away look at and say, I believe that these apply in understanding the relative age dates of rocks that we see here in the Grand Canyon. So, if you said cross-cutting relationships, superposition, and original horizontality, you have a really good eye. The two that jump out are superposition, the rocks are stacked. Original horizontality, oh, I don't have lateral continuity up here. What the heck? Lecture's over, class is canceled, let's go home. Lateral continuity also. But what you might not see are these erosional surfaces called unconformities that show cross-cutting relationships. So the erosion has cut into the overlying bedrock and it has created what's known as an unconformity. See my next lecture for that. But the big three that we're looking at is superposition, original horizontality, and lateral continuity. Thank you, Grand Canyon. So we've got our principles of stratigraphy that help to understand the relative age dates of different sequences of rocks. And it's this way that we can help to understand, or we are aided in understanding the geological history of an area, because geology, rocks, they're messy. And you've got to be a geologic investigator in order to figure out how the world came to be, how these rocks, how these sequences came to be the way that they are. And using the principles of stratigraphy can help. Thank you so much. I'll see you again.